Hey everybody, so hopefully you've had a chance to take a look at the pre-lab exercise. This is a video just kind of rolling through those questions and giving you an idea of how you would do them, but hopefully you've tried them on your own first so that you're able to come here and kind of check your work rather than just kind of hear the answer, because there's a little bit more learning that goes on that way. So anyways, you can see the two questions here on the board, and I've put the answers in the blue ink for you. The first thing I wanted to point out here is this question where you're calculating how much mass of the iron 2 ammonium sulfate hexahydrate you need in order to make the solution that the procedure talks about so that you can titrate that sample. Now, it says that you need a solution that's 50 milliliters in volume with a concentration of 0.0500 moles per liter. And in order to calculate how many moles I have here, I want to change this 50 milliliters into liters. So I'm going to erase that and put how many liters 50 milliliters is on the board. Now you'll notice these two numbers are the same. That's merely coincidental. Was not that we took this number and made it this number. Those numbers are different. This is a volume, this is a concentration. We want to make a solution of iron 2 ammonium sulfate hexahydrate. We're going to make a solution of that's 50 milliliters in volume with a concentration of 0.0500 moles per liter. So if we do the math here, you can see that the liters cancel out, and that gives us how many moles we would have in that solution. Now if we use the molar mass of this substance, which is this guy right here, 392.21 grams per mole, you can see that the moles cancel out, and then that leaves us with just units of grams, which gives us 0.981 grams that we would need to weigh out on the scale and dissolve in a solution so that we have a solution that is 50 milliliters. Follow the procedure carefully as you kind of look at how that's done, but essentially you're just kind of dissolving the crystals first, and then you'll use water to bring the volume up to 50 exactly. Problem number 2 is it just asks you to write a balanced redox reaction for this problem. We've done lots of those questions where you have to write a balanced redox reaction from a written problem. And so this is no different. You're just given the information here. So write out a species listed for this problem, and then you use your data booklet to identify what's your strongest oxidizing agent, which one's your strongest reducing agent. And so for this one right here, this is my strongest oxidizing agent, and looking in my booklet, I'll find out that Fe2 positive is my strongest reducing agent. So once I've done that, I come over here and write my corresponding half reactions for those. This is my reduction half reaction for the permanganate and hydrogen ions. This is my oxidation half reaction for my Fe2 positive ion, that's my reducing agent. And then you'll notice that I balanced the electrons out, multiplied this whole reaction by 5 so that I could cancel out my electrons. Again, I want to point out, when you're doing your electrical potential calculations, make sure that if you're flipping this reaction from the reduction half reaction that's in the booklet to be an oxidation half reaction, you have to flip the sign of this number. And then also, if this equation gets multiplied by any number, in this case it was multiplied by 5, you do not multiply that number by 5. So just to point that out again and to reiterate the importance of that. Then once you cancel out the electrons, you just write out what you have left over. Here it is on the board, and you can see my net electrical potential for that reaction is a positive 0.74.